Alright, so welcome to this lesson. Here we are going to be looking at measures of central tendency. Alright, so a measure of central tendency is any statistic that summarizes data on a variable by supplying a single value around which other values congregate. So what we mean by central tendency? We are talking about the fact that when you have your data, for instance, maybe your data has something like 3, 2, 3, maybe 4, and then maybe it may have 4, may have, and it may have, so let's assume that you have it this way, and then you rearrange, it may become 2, 3, 4, and then we have 4 again, and then finally 5, and then we have 6. The idea is that there is a particular value that let's assume we have 7 here also, or 6 again, 6 repeated. The idea is that there is a particular value around which every of the values you have, a particular value that is, or rather there's a particular value surrounded by every other value, meaning that, let me use a dot. For instance, let's assume these are your data points. We are assuming that there is a particular value that they congregate around. So some may be far from that particular value, some may be very close, but that value is the central value. So in this case, if you look at what we have here, supposing we decide to use what we call the median, you put this here, you put this here, then we say all the values are actually around 4. So they congregate around 4. 4 is in the middle, and every value you have here congregates around it. It's 4 is the central value. So that's what we are trying to say when we say central tendency. So, but the median is not the only central tendency we have. We have the mean, the median, and the mode, and the mid-range. So let's look at central tendency again. So we are looking at a value that can be representative of the data. So one particular value that can summarize the whole data, so that you know that, okay, the value actually congregate around this particular value. So it's the average, is the middle value. That's what we're trying to what we are trying to say. And then the other, as I said, the measures of central tendency are the mean, the median, the mode, and the mid-range. So now we go on. Now, if we have our data to be in the form x1, x2, just like I did here, in this form, like that. So your data may be like that sometimes, and then you can use the following formula to obtain your mean, mode, median, and the mid-range. So summation x, just add everything that you have here and divide by n. So just like in this example, what would have done would have been, we just say 2 plus 3 plus 4 plus 4 plus 5 plus 6 plus 7. And what's the number of observation? 1, 2, 3, 4, 5, 6, 7. So after adding everything, we divide by 7. So that's what that's talking about. Now the mode is the observation with the maximum number of occurrence. If you look at what we had here, oh, sorry, I wrote 6 here, so I was supposed to have had 6 here. So if we had 6 here, then we will have 2 modes, because 2 numbers appear, and that's what we call bimodal. This kind of a distribution that has 2 modes may not be so good for us when we're trying to study certain things, so we don't want that. So let's just put 7 here. Then we'll have 7, and that way we can have only 1 mode. The number that appears, that has the most number, or a number that has the highest occurrence, highest number of occurrence. So, and that will be 4 in this case, since we don't have any number occurring twice. 4 occurs twice, and that's the maximum number of times that end of the values show. Now, so your median will be the n plus 1 over 2, okay, so elements. So this n plus 1, for instance, the other time we had 7 observations here. So 7 plus 1 is 8. So 7 plus 1, that's n. N is 7 divided by 2, and that's going to give us 8 divided by 2, and that will be 4. So the fourth observation here was actually our median. 1, 2, 3, 4. This actually. That is because n is odd this time. So n was odd and n was 7. So but when n is even, that means n is something like maybe you have 2, 4, 6, 8, 10, like that. Then you need to find the n over 2. Okay, so you can say that now n over 2 element, if you say it that way, don't mind me. So you are going to find that. So, and you find the element that takes position n plus 1 over 2 also. And then you now need to add those two elements and divide by 2. So let's look at that here shortly. Supposing that we had no 7th element, we had just 6 of them. Then this time around, n over 2 is going to give us 6 over 2, and that will be equal to 3. Then n plus n over 2 plus 1 will give us, so you already know, 3 plus 1, and that will be 4. So it means that we're going to be taking the third and fourth elements and joining them and dividing by 2. In this case, coincidentally, this is the third element and this is the fourth element. They are the same. So if you do 4 plus 4 and you divide by 2, you're still going to have 4. But in some cases, you may have another number here, for instance. So it may be 5 or 6 or any number. So you'd have just done 4 plus 5 divided by 2, and that would have been 9 over 2. Sorry, 9 over 2, and that would have given us 4.5. So please take note of that. So that's how you get your median. Now going on, that is when n is even. Please take note of that. Your mid-range is the maximum observation plus the minimum observation divided by 2. So the maximum observation, from what you can see here, is 6 from data currently. So your mid-range would have been 6 plus the minimum observation is 2. 6 plus 2, so divided by 2, and that would have given us 8 over 2, and would have had 4. Okay, so that's that about the mid-range. So let's look at, so we are done with that. But that one, what we looked at just now, is actually for a situation where your data is just, the values that you have in your variable, and just arrange that way. So your data is just somewhat like what I have shown here. So like that. But what about a situation where your data was put in a frequency distribution form, but on group frequency distribution? Now you have counted each of the 12s that you have. You counted them and you had 20. Counted the 14 and you had 16. And like that until you're done. Now your formula will have some small differences, just some small differences, or some differences rather. And for instance, you will have f frequency multiplying your value here, and then you divide. So the sum of the frequency will give you your n also. So add everything here, whatever it gives you, that's the meaning of this. So add everything you have here, whatever you get here, you put that here. But this one, fi multiplied by xi, means that multiply this by this, then add it to the multiplication of this by this. So something like 12 times 20 plus 14 times 16 plus, you keep going. So that's just what we are doing. 15 times 21, 16 times plus 16 times 15 plus 17 times 5, like that. You keep going. So the mode, any number that has the highest frequency here will give you will be the mode. For instance, now the mode is going to be 15 in this data set. Why? Because it has the highest number of occurrence, and that's 21. And you go your median, the first value with a cumulative frequency of at least n plus 1 divided by 2 if n is odd. So when you do n plus 1 divided by 2, we're going to see that later on. Then the average of the value, so the average of the first value with a cumulative frequency of n over 2 and the first value with a cumulative frequency of n over 2 plus 1 if n is even. So in this case, we'll look at what that means. But that will only be done after you have arranged your, so your frequency distribution is actually going to be in ascending order. I mean, maybe in descending order too, but at least it has to be in order. So ascending order, preferably from 12, so 14, 15, 16, so you're going upward as you start from the smallest value to the highest value. So the maximum, the mid-range is still going to be the maximum observation plus the minimum observation divided by 2. So you're still going to do that. So in this case, 12 plus, maximum first, 17 plus 12 divided by 2, and that will be 29 divided by 2. All right, so let's look at some examples on this and see how it can be done. So supposing that you are given data, okay, I don't want to do that of the, because I've done something like that already. So let's do that of the ungrouped frequency distribution. Supposing you have this data that we have here. Now, what you're going to do is, so 12, you want to find the mean now, you already have a formula. So you need to multiply the frequency here by, okay, I need to quickly correct something. Please look at it again. Frequency should come first according to what I've written here, but I put the x values first. So this is x, this is fi, xi, fi. So instead of that, we should have 20 multiplied by 12. So so that we can have something that tallies with, and then 16 multiplied by 14. So you can tally with what we have in the formula, or it can, yeah, so we go, the next one should be 15. So it can look like what we have in the formula. 15 multiplied by 21, no, 21 multiplied by 15. Then 15 multiplied by 16, and then finally 5 multiplied by 17. So when you have done that, sorry, okay, when you have done that, you're going to have 1,104 divided by 77, and that should give us 14.3377. So don't forget, it's preferable for you to have your answer in 4 decimal places. All right, so the mode. What's going to be the mode? The mode is going to be 15. Why? 15 has the highest number of occurrence from the frequency, 21. All right, so you go on your median. What's going to be your median? You need to check, is n odd? N is 77, so n is odd, yes. So you're going to have the, just like we said in the formula, the n plus 1 over 2, the element that is in position n plus 1 over 2. So that will give us 78 when you do that, 78 divided by 2, and that will be 39. And the 39th element, how do you get 39th element? Keep adding the frequencies. So 20 plus 16, that should give you 36, so it's not 29 yet. So if you add 21 to 36, that's going to be greater than 39. So that's the first class that has a frequency of at least 39. I mean, this is the first first value that has a frequency of at least 39. So definitely it means that your 39th value is going to be somewhat around so it definitely has to be 15. It means that, so if you get what I'm saying, it means that your 15, 15, when you get here, your 31st element, let me show what I'm saying. I mean 36th element, sorry, this is a different marker. Your 36th element is going to be this. And so that means that when you are writing your 14, dot, 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 so this will be the 36th element. 36th element. And so your 37th element will be 15. And the 38th element is also going to be 15. And we are going to have more 15 until, so 36 plus 21. 36 plus 21 will be 57. So the 57th element is also going to be 15. But the 58th element will now be 16. So we are saying that the element in position 38 is 15. So, and that means that's our median. That's how we got that. But in a situation where it is even, then you are going to need to find, so let's assume it was 78, or let's say 76, for instance, divided by 2, that would have given us 38. Then you now do 76 plus 1, 76 divided by 2 plus 1, and that would have given us 38 plus 1, that would be 39. So you now start checking. If you continue, you'll find out that the 38th element will be obtained in this position, 15. And the 39th element will be obtained in this position, also 15. So that means 15 plus 15 divided by 2, that's going to give you 15. So your median would have been 15. So in some situations, your 38th element might have fallen or might be found in this place, while your 39th element might be found in this place. So then you just need to say 14 plus 15 divided by 2, and then you get your answer. So that's that about that. So we go to the mid-range. The mid-range, what's the maximum observation? Maximum observation here is 17, and the minimum is 12. So you add them together, 17 plus 12 divided by 2, that should give you 14.5. So let's look at when you have a grouped frequency distribution. That one was ungrouped frequency distribution. Now the formula for the group your group frequency distribution is something like this. Bearing note all that you have, okay, up there. Now this is class width, class boundary, class interval, class mid-mark, frequency. So now we go on. We will not be using this, please take note, we will not be using the greater than type of cumulative frequency. Now, so please take note of what you have there in the formula. You can pause the video if need be and check what you are seeing. So I'll just go slowly. In fact, I believe you need to pause the video and check the formula that you are seeing. So I'll also leave this also for a while. Okay. All right. So the mode and the median are the ones with the great stuffs. Now let's go on and see how you could actually use these ones now. Now, when you have a group frequency distribution like this, the only difference between this and the one we did before is that now you're going to be using the class mid-mark as your X value. So the class mid-mark, X. So you can see X values now. You have 2.5, you have 6.5, you have 10.5, you have 14.5. And the frequencies, 3, you can see 3, 6, 2, 4, which are what you have here, 3, 6, 2, 4. So you just multiply them accordingly and divide, because when you sum all of what you have here, you get 15. If you sum all the frequencies here, you get 15. And then you divide by 15 to get that value, 8.3667. So what about the mode? The mode, this time around, we want to know the frequency of the modal class. Check them. Which one has the highest number of occurrence? The highest number of occurrence is 6. So the modal class becomes this class, the class of 5 to 8. And what's the lower class boundary of this class? It is 4.5. So the modal class is this class because it has the highest frequency, and the lower class boundary is 4.5. So that's the meaning of L subscript MO. That's 4.5. And what's the frequency of the modal class? The frequency of the modal class is 6. You can see that here. It's 6. So we'll write 6 here. And what is the frequency of the class before the modal class? That is 3. How? You can see that here. This is the class before that class, and the frequency is 3. Now you go on again. So your F2 is the frequency of the class after the modal class. What's the frequency of the class after the modal class? You have it to be 2. You can see that here. So this is the class after the modal class, this class, and the frequency is 2. So what's the class width? The class width you can see already is constant for all of them. That's 4. And that's what we have noted by C. And so you fix everything in your formula, and then you get a mode of 6.2143. Okay. So the median. The median, in order to obtain the median, you need to obtain the median class. And how do you obtain the median class? You need to divide your frequency just the way we said before. So the way you look for your frequency, the way you look for your median. So you do that with the frequency, and once you obtain the median, the way I did before, only that this time around, for instance, you have 15. So 15 divided by 2. 15 is odd, so you just say 15 plus 1 divided by 2, and that will give us 16 divided by 2, and 16 divided by 2 should be 8. So you keep adding the frequency. So 3 plus 6, and 9 is the first time you have, so something that is at least greater than or equal to 8. So the first time you have that is in this place. So since it means that our 8th observation will also be in this, our median will also be here. What I have done is to use the formula that we have been talking about here. So you can go through it again and see how. So the median value will fall in that place. I've explained that earlier on. So when you have obtained, so since I know that the median will fall around here, don't forget, we are doing a class frequency, a group frequency distribution this time around. Let me go again. Median would have been, because we have 15 observations, 3 plus 1 divided by 2. So as you can see here, the n plus 1 over 2, okay, so the element in the position n plus 1 over 2, when n is odd, is your median. So I'm doing that, I'm using that here. It applies to your, don't forget, it applies to your group frequency distribution as well as your your ungroup frequency distribution, and as well as your grouped frequency distribution. So we haven't done that. That will give me 16 divided by 2, and that will give me 8. Now that I have 8, I've drawn in this to show that I'm not using that. Okay, now that I have 8, so I need to start looking for where my 8th observation will fall. So 3, and 3 is less than 8. So for 3 plus 6 rather, gives me 9. So definitely the 8th observation is going to fall somewhere around here. That's what I'm trying to say. And so it means that the median class is going to, because we said the 8th element should be our median, so the median class is going to be somewhat around this. So, but we cannot just put the 8th element and say the 8th element, because we don't even know what the 8th element should be, because we have a group frequency distribution. So we take the median class and begin something on that. So don't forget the median class, the lower class boundary is 4.5, and the frequency is 6. So let's go back. Now that we know the median class to be, that's the meaning of L subscript MD 4.5. In this case, the median, the lower class boundary of the median class is the same thing as the lower class boundary of the modal class. But in some cases, they may not be the same place. So they are 4.5 here. What I'm saying is this is equal to this here, but it's not going to be so in every case. So please take note of that. What's the class? In the frequency of the median class, we said is 6. Then the cumulative frequency of the class preceding the median class, the class that comes before the median class, the cumulative frequency of it, let's go back and check. So the cumulative frequency of the class that comes before the median class is actually 3. So supposing the median class had been here, then the cumulative frequency of the class that comes before it would have been 9. But in this case, the median class is this, and the cumulative frequency that comes with it is of the class that comes before it is actually 3. So we're going to use that. So that is the meaning of F substitute CM. So we write that there, and the class size is 4 as before. So when we substitute everything here, now you may ask and say, what's the meaning of summation FI? It means add all the frequencies you have. So look at this again. So if you add everything here, you're going to get 15. That's the meaning of the summation FI. So if you add everything here, you get 15. All right, so go to 15. Now that we know that, we are going to be dividing that 15 by 2. So that's what we are doing there. 15 divided by 2 minus every other thing that we have found, we fix them, and then we get a median of 7. So the mid-range is, this time around, you are going to be using the mid-mark values of your classes. So when you come, you want to get the maximum. The maximum is going to be 14.5, so mid-mark, and the minimum is 2.5. So you add them and divide by 2, and you're going to get a value of, you can see that. So you add 17 divided by 2, and that will give you 8.5. So with that, we have come to the end of this lesson. Thank you.